Hello everyone. Hope you're having a good day. I just want to go over a couple examples with you to practice some of what we talked about yesterday with finding the sine, cosine, tangent, secant, cosecant, and cotangent for our 45-degree angles, 30-degree angles, and 60-degree angles. Basically, our special angles in quadrant one. So number one, we're actually finding three different trig functions here, or the sine of three different angles. So we'll just go through how this works. So for the sine of 45 degrees, I'm going to refer to this trig toolbox unit circle and triangles. Sine of 45 degrees, if we come down this toolbox, we see our 45, 45, 90 triangle. We know sine is opposite over hypotenuse. So if I want to find the sine of 45 degrees, I'm looking at my 45, 45, 90 triangle. Pick one of the 45s. The opposite side would be 1 over the hypotenuse is a square root of 2. And when I rationalize that, I find the sine of 45 degrees is going to be root 2 over 2. So the sine of 45 degrees is going to be root 2 over 2. Then I want to add to that the sine of 30 degrees. Well, to find the sine of 30 degrees, and go to the toolbox, look at my 30, 60, 90 triangle. I'm still doing sine, so I want to do opposite over hypotenuse. Well, with respect to my 30-degree angle, the opposite side would be 1, and the hypotenuse would be 2. So sine of 30 degrees is going to be opposite side, which is 1, over hypotenuse, which is 2. So sine of 30 degrees is 1/2. And then the last section with this, or last part of this, is a sine of 60 degrees. So again, I'm going to go to my 30, 60, 90 triangle and do sine of 60. So here's my 30, 60, 90 triangle. Sine is still opposite over hypotenuse. With respect to 60 degrees, opposite side is root 3, hypotenuse is 2. So the sine of 60 degrees is square root of 3 over 2. So there's not a whole lot we can do with these three numbers since we have a common denominator. That's about all we can do. We can do root 2 plus 1 plus root 3 all over 2. So that doesn't simplify all that nicely. For number 3, we have the cosecant of 45 degrees. So I want to do the cosecant of 45. I'll go to that toolbox, 45 degrees. Here I know cosecant is reciprocal of sine. So if sine is opposite over hypotenuse, and I want to do the cosecant of 45 degrees, I'm going to do the hypotenuse over the opposite. So for 45 degrees, my hypotenuse is a square root of 2, and my adjacent side, or my opposite side rather, is just 1. So the cosecant of 45 degrees is just the square root of 2. And then I'm going to do the cosecant of 45 times the sine of 60 degrees. Well, we have the sine of 60 from that last problem. We know the sine of 60 is the square root of 3 over 2. Plus a secant of 60. So go to the trig toolbox. I know secant is reciprocal of cosine. So if I want to find the secant of 60 degrees, instead of doing adjacent over hypotenuse, I'm going to do hypotenuse over adjacent. And for my 30, 60, 90 triangle, my hypotenuse is 2. And adjacent to that 60-degree angle is a side length of 1. So the secant of 60 degrees is just 2. And we're going to multiply that then by the sine of 90. Now don't forget our quadrantal angles. We still have those quadrantal angles with the zeros and the ones and the ordered pairs we want to consider. So if we go to the toolbox, 90 degrees is up here. Here's our ordered pair. We know the sine in terms of x's, y's, and r's is equal to y over r. So at 90 degrees, my y value is 1, my r value is 1, sine of 90 degrees is 1. So when we simplify that, we can do the square root of 2, think of that as being over 1, times the square root of 3 over 2 gives us root 6 over 2 plus 2 times 1 is just 2. Okay. So use those examples and do the same work on numbers 2, 4, 6, 8, and 10. They all work out to be nicer, neater answers than examples 1 and 3. Again, use that toolbox. Don't forget about your quadrantal angles. You'll see some of those come up. You got your 180 degrees here. There's 0 degrees down here. So those don't go away. They're still angles you should know. For the true false, you're basically doing the left-hand side and see if that is equal to the right-hand side. So for this one, we're doing 3 times the tangent of 45 degrees. So for the tangent of 45 degrees, toolbox, here's my 45, 45, 90 triangle. I know tangent is opposite over adjacent. So if I pick this 45-degree angle, opposite side is 1, adjacent side is 1. 1 divided by 1 is just 1. So the tangent of 45 degrees is 1. Then for the cosecant of 30, cosecant I know is the reciprocal of sine. So if I want to find a cosecant of 30 degrees, if sine is opposite of hypotenuse, then cosecant is hypotenuse over opposite. And at 30 degrees, my hypotenuse is 2. The opposite side from 30 degrees is just 1. So you have 2 over 1, which is 2. So the cosecant of 30 degrees is 2. And I want to see if 3 times 1 minus 2 is equal to 1. Well, obviously 3 times 1 is 3. 3 minus 2 is 1, and 1 does equal 1. So this is true. So I'd like you to try numbers 2 and 3 also. See if these are true or false. Verify with the values you find for the trig functions, those angles. Pause the video, take some time, work on 2 through 10, the evens, and numbers 2 and 3. And once you're done with those, come back to this video and we'll go over the next topic. Come back. So we looked at the 6 trig functions for 30 degrees, 45, and 60. What we're going to look at right now is the trig functions for the other special angles in quadrant 2, quadrant 3, and quadrant 4. So go over how that's done. So I mentioned in class yesterday reference angles. Remember, the reference angle is just the number of degrees between your given angle and the nearest x-axis. So it's going to be the number of degrees between your given angle and the nearest x-axis. Look at a couple examples here. So for 40 degrees, if we want to find the reference angle 40 degrees is about here. Our nearest x-axis is 0. So the reference angle for 40 degrees is just 40 degrees. We'll use the theta prime to represent 40 degrees as a reference angle. If we're looking at the sine of 140 degrees, 140 degrees is about here. Nearest x-axis is 180 degrees. Number of degrees between 140 and 180 is 40 degrees. So for that reference angle, we also have 40 degrees. For the sine of 220 degrees, 220 is about here. Nearest x-axis is the 180 degrees. So between 180 and 220 The difference there is 40 degrees. The reference angle for this one's also 40 degrees. And if we do the sine of 320, looking at 320 degrees, 320 is going to be about here. Our nearest x-axis is 360 degrees. So the difference between 320 degrees and 360 degrees is 40 degrees. Our reference angle, again, is going to be 40 degrees. So if we look at these two examples, for 150 degrees, reference angle is going to be, again, the number of degrees between the given angle, the nearest x-axis, which is 180. So if the given angle is 150, nearest x-axis is 180, this 30 degrees is our reference angle. For negative 100 degrees, probably easiest to sketch it. Negative 100 degrees is going to look something like this, a little bit past 90. Remember, negative, we're rotating clockwise. So negative 100. The nearest x-axis is 180 degrees. Now, reference angle is always going to be a positive number. So the number of degrees between 100 and 180 is going to be 80 degrees. Again, the negative just tells us to rotate clockwise. We're looking at the difference between the angle and the nearest x-axis. So we can use those reference angles to find the sine, cosine, the 6 trig functions of angles other than 30, 45, and 60. There's a few, basically 3 different steps we're going to be doing. Here are the steps. You want to find the reference angle, the quadrant, whether it's going to make that positive or negative, and then the ratio. The order here doesn't matter. So let me go through a couple examples here, and that'll be it. So for the cosine of 120 degrees, come over here where I have a little bit more room. So a reference angle, think about 120 degrees, about here. Nearest x-axis is 180. So a reference angle is going to be 60 degrees. What that tells us is we can go and do the cosine of 60 degrees. Because the reference angle for 120 is 60 degrees, the cosine of 60 and the cosine of 120 are going to be very, very similar. So cosine of 60, now we're back to what we were doing yesterday. The trig toolbox, cosine of 60 degrees. Here's my 60-degree angle. I know cosine is adjacent over hypotenuse. So 60 degrees, the adjacent side is 1, hypotenuse is 2. So the cosine of 60 degrees is 1 over 2, or 1/2. What that means is a cosine of 120 degrees is also going to be 1/2. But there's one thing we have to check yet. 120 degrees is in quadrant 2. And we know that in quadrant 2, only sine and its reciprocal cosecant are positive, meaning everything else, including cosine, is negative. So 120 degrees is in quadrant 2, and in quadrant 2, cosine is negative. So we're going to have a negative 1/2. So you have to make sure you check your quadrant at the end to find out whether your sine or your trig function should be positive or negative. We do the sine of 210, and then we'll stop there. So 210 degrees, reference angle. So from 210, which is here, to the nearest x-axis is 30 degrees. Our reference angle is 30 degrees. That means we're doing a sine of 30 degrees. The trig toolbox, sine, opposite over hypotenuse, 30 degrees, opposite is 1, hypotenuse is 2. So sine of 30 is 1 over 2, or 1/2. That means the sine of 210, the fraction, is also going to be 1/2. Well, we know 210 is in quadrant 3, and in quadrant 3, only tangent and cotangent are positive, which means everything else is negative. So we want to do negative 1/2. Um,